Hey, welcome to today's video on simulation of the pedestrian subway entrance or using Anylogic. In the previous video, we're able to have a little introduction into Anylogic and some of the terminologies and some of the tools we use in Anylogic software. Earlier, I explained that in simulation, we have different popular softwares that are used for simulation. And one of those popular softwares is Anylogic. We've been able to do a little video. We made some videos on the use of Sumo, in which you can find on my page. And today we want to take a tutorial or make an example or a video on the subway entrance or we know when we're talking about subway entrance or that means it has to do with a train, and when passengers are coming trying to make use of the train, they come through the entrance. We know some of those passengers when they want to do this, some of them might have bought their tickets maybe online or probably days before, but we know there are some of them who might have gotten their tickets online. But we still know there are some passengers who come to the train station or the train hall with the expectation that they will be buying their tickets at the train station, what we can call the subway hall. And that is where we have the fare gate. The fare gate is just a point where tickets can be bought before heading to the train. So these are some of the things we're going to be taking a look at during the course of this video. We're going to be seeing how passengers move into the subway hall and some of the activity that takes place in the subway hall, in which I already explained in the previous video. But for the sake of this video, that is where we are going to be having the fare gates where they can buy their tickets, and after doing that then they can head to the train. And also we are going to be looking into the line of service or the service line, how it works and how it can be introduced into the model or the simulation and the movement to the train. I think the last part we're also going to be looking at is the density map. We're going to have an overview of what it looks like and how we can introduce it in the course of this video. So without wasting much time, let's go. So like I said, we are going to be starting with the movement, like that is the subway entrance or using any logic. And the first part we need to do, or before we even go into this, it is very important for anyone who wants to follow me step by step. The first thing you need to do is to be able to download Anylogic. You can go on Google and download Anylogic. It is quite easy and is also free. So you can download it, the learning mode. After downloading, I think it's very straightforward. Just follow the instruction and install it on your PC, on your laptop, or whichever device that it can run with. So then after doing that, you can open the application. Then from there we can proceed together at this point. So in order not to waste much time with the process of downloading, I already downloaded it on my laptop, so we can just proceed from that point. So here we have the phase one. The phase one is simulating a simple pedestrian flow, like we said. And in order to do that, the first thing we need to do is to be able to create a model. So by opening any logic, after opening the any logic application, then we can create a new account. So in the when we're saying we're creating a new model, it's just like you're creating an account or probably starting a new model by putting whatever name you want to use to start the application or you want to use for the simulation. So you can put any name. So but without wasting too much time, we this is my overview. This is the overview of the Anylogic Personal Learning Edition, and you can see this is the 8.95 um, edition, and this is what the interface looks like, the palette, the project, and these some of those things I already explained in the previous video. And under the palette we have the wall, the rectangular wall, the target line. I already explained this in the previous video. The we have the service with lines, also service with areas, and you can see just a little introduction into what it's all about here. So when other we have the pet source, I already explained this. That is the source where people are coming in from, when they're coming into the simulation. Then we have the pet to go, that is showing how the movement is like. And we have what we call the pet sync. It's just talking about when they're heading out of the simulation or maybe go to trains, as we are going to be making use of in this video. But without wasting much time on that, let us get started. So the first thing we're going to do is to open a new, come to new, then we have the model. So when we have this, then it opens this way. So what do we want to save it with? Let's use pedestrian flow. Let's just use something. So whatever name you want to use, you can do that. Just put in anything you want to, and so as you can see, it changes here. We have the pedestrian flow and under the Java page, and this is the location. If you want to change the location where you want yours to appear afterwards, you can also do that under the browse. And another thing that is very important is changing the model time unit. Here it's in seconds, but you can just put it to minutes. Then after when you've been able to do that, then you can click on the finish. Then it creates a new model. This might take a few seconds to create before we start the whole process. Now, since we want to, pending when this is loading, one of the things, since we want to create a subway all, how can I call it? There is an image in which we're going to be using to create the hall. I'll be adding it in the attachment to this video when it's been posted, so you can check under the attachment point. I'll add it there so you can easily download the image if you want to also do the same. So, and for that also, you can also check on the Anylogic website. You can see the image there. But as it stands, okay, we have it already open, and we're going to be making use of that image to have to set up our subway all. So the properties, in order to have a bigger view of the interface, you can just close. So we have something like this. So after one we have been able to do this, so here we can see the palette. Under the palette we have the pedestrian library where we have some of this information, but that is not what we are after now. What we need is to be able to import the image we are going to be using, or we are going to be having other elements too. So what we are going to do is that you can come under presentation. I'm trying to take it, step by step, so you can also follow. Come under presentation, you can say this is presentation, you click on it. So then you come under image, because under in presentation we have image. So when you have to drag this image to the main page. So when you drag this way, you can just drop at any point. So the moment you do that, since we want to use an image, then it will lead you to wherever you have saved the picture or the PNG drawing. So this is it for this sake. Then I can open. Then this is what we have. So this is just a little subway entrance. Oh yeah, we have the entrance, we have the turnstile, then we have to train. So this is just an overview of it. This is an overview of it. So the next thing we're going to be doing at this point is we need to lock this layout, or we need to lock this image. This helps us to be able to keep every information we're going to be putting on this image there. So there won't be any case where some of these informations might leave. So we just need to be able to lock this in order to be able to add other elements to the image. And in order to do that, then you can come under view where we have the properties. So here we have the lock. So you just click on it, then it's already locked. Then you can close this. If you want to be sure that that is done, you can just go back again just to be sure that, okay, am I sure what I've been able to lock the image, so you can see it's locked. Then you can just close, and here we have it. So that is the next thing. So after one we've been able to do that, the next thing is to be able to build a wall around the image to show that everything we're doing is within that confinement of this image. And in order to do that, we also so in order to be able to do that, yes, we come under the pedestrian library here. So then we have here the wall. Now this is one thing you need to note. So when you want to use this wall, you need to left click, like double left click, like click it twice. So when we do that, you must make sure that the sign of this wall here changes to something like a pen or a pencil. So this, it must change. That means when it changes this way, it shows that we've been able to pick the two. So we can come to this point because we need to make it, put it around. So you can see you have something like this. Maybe you do something like this. So after when we're done, you also click it twice. That is left click twice. Then we have this. So you can see we've been able to create a wall around it. We've been able to create a wall around it. So if you do not understand what I've just done, I would Control Z, then take it again. So just to have a better understanding of it. So this is the wall. You click it twice. That is, you left click twice. So you can see it has changed to a pen or a pencil. Then you can start from the beginning point of this. Left click once, so it activates it, and we have something this way. So at each point where we want to make a curve, you have to left click once, then you continue, left click. When I get to this point, left click, I continue again. When I get to this point, left click, continue. Continue again. When you get to this point, this curve point, left click, then to this point again, then left click. Since we are done, we can just double click, then we have this again. So that is how we establish the wall around the image or the picture. So now that we have been able to do that, the next thing we're going to be doing, or the next step, is the introduction of the entry point and the exit point. Now, we just have it here as a word or entrance, but we need to be able to create or introduce it into the image. And how do we do that? I already explained in the previous video. We bring in the target line. So we can see in pedestrian, simulation model defines pedestrian entrance, waiting location, or the movement destination. So we're going to be creating the entrance, and we're also going to be creating the movement destination, that is exiting out of the hall. So the first thing is that we have to, the same way we did for a wall, we have to double click. When we double click, the arrow there will change to the pencil, something like this. Then at the point of this entrance, we just right left click, then just create something like this, then we left click, drop it. So this is it. Been able to create an entrance. At this point, if you want to move it, maybe move it upward or downward, you can just move it this way if you want to, but we don't have any cost to do that, so we can just leave it that way. So after when we've been able to create this, we'll also do the same thing for the exit point here, to the, that is to train. We double click, we come to this point, then creating something like that, then double click. So we've been able to create the destination, that is the exit point. So this is how we use target line to create the entry point and the exit point using Anylogic. So after when this is done, then we need to be able to check out the properties and change some information in the properties. So since we're done with that, we'll click on this. This is the first one, the target line, the first target line. Then you can just go under the properties. So this is the properties. We can just decide to change this from target line to, let's say, entry line. Let's just change it to entry, because since we're having two lines, we don't want them having the same name. So let's just show this. Let's make this quite different from the other by saying this is the entry line, then that can be the target line. So after when we've been able to do that, we can close this. So if you want to be sure that the name has changed, you can just click on it again, go back just to confirm. So you can see entry line. So we have it and we close. So after when so the next step we're going to be looking into now is the introduction of our pet source, the pet service, and the pet link by dragging them into the model. I already explained what the pet source is all about. Is the entry point, and the pet services, looking at the activities that are taking place within the hall. Then the pet sync is the destination point. So without wasting much time, so under the pedestrian type, that is where we have it, the pet source. So this one you will have to drag it. You can see I've been able to drag it in. That's the pet source. So we have to connect the pet source to the pet link. So dragging in uh, the pet to go this way. You can see there has to be a level of connection that way. Then the last part will be the pet sync, also having that connection this way. So the idea behind this is that the pet source is it blocks the pet source block, it generates pedestrians. It is at that point we generate the pedestrians or the passengers. It is usually used as the starting point of the pedestrian flow, just like what we already have here. So it models the passengers arrival or the commuters arrival into the entrance hall. But when it comes to the pet to go, it moves pedestrians from the current location to a new one. So that is movement from one location to another new one. And we had this block to model how passengers move from the entry to the subway train. So that is why we have the pedestrian and pet to go. Then the last part is the pet sync. We know this block, it helps to dispose incoming pedestrians and is usually used as an endpoint of the pedestrian flow, just like what we have at the end. So we are going to be connecting as we've had the entry line, the entry line through the target line, which is the point of the pet source. Then the pet go is the activity that takes place within the entrance, or while the pet sync is what we have the target line, the other one to train that shows the end point of the pedestrian flow. So the next thing we're going to do is to change some of the configurations. So rather than using pet source as the name, we can change the name. Just double click and you can change to inflow source. That is the source of our inflow. Then for the pet to go, okay, but still under this, if we want to change the properties, coming under the properties, so the name, been able to change it to inflow source, which already done. So you leave this, we'll still leave this as the line. So for the target line, for the inflow source, so which of the target line do we want it to represent? So we click it here. Do we want it to be the entry line or the target line? But it's going to be the entry line, so you click the entry line. And then moving from that, yes, arrive according to the rate. So we leave that the arrival rate, maybe probably we can change this to 4,000. And this one is per hour. So those are just the things we change here, and that is it. So then we can close. Like I said, if you still want to go back to confirm if everything we've done is still intact, you can just go to the properties again, and we can see it's still there. So that is it for the inflow. So then we go to the pet to go, the next one. You can check under the properties, like here, the reach target, yes, the pet to go, the target line. So in this time around, we can just change it to go to train. That is because this is the point where you need the movement to the train. So just we can change it to go to train. Then which target will leave this? That's the line. Then the target line. What's the target line? Since we are moving to the train point, we can change it to the target line. That is the destination point, and that is it for that. So we can see the name has changed, go to trends. So, but if you still want to confirm like I did, we can still do that to be sure that if the informations are still there, no go to trend and the target line. So pet sync, we will not change anything under the pet sync. No, there is nothing to change. But if you want to check out the properties, this is what the properties looks like. So there is nothing to change. There is nothing to add. We can just leave it as pet sync. But if you want to change the name to anything that suits you, you can also do that. So this this is it. So we've been able to create a flow of, these are under the pedestrian type. Here we have a pedestrian type. So pedestrian has to do with the people, the passengers, the commuters. And these are some of the informations we use for them. And we've been able to create the pet source, that is the coming in of the pedestrian, or of the passengers into the hall. And this is the go-to train, and the go-to train movement within the subway entrance, or then the pet source that is exiting the hall. And we've been able to change the configuration. So how many people are we looking at, how many passengers are we looking at? We changed it to 4,000. So since we've been able to do that, we can just come here to run the pedestrian flow, just to have an idea of what it's going to look like. So you can just click on this, then we'll see how this works. So now the model can start. So we can see the movement from the entry line, that is the entrance, coming into the subway entrance hall and exiting to train at this point, the destination. So from this point, because we've not created anything within the subway entrance hall, it will have shown the movement of these people. These are the commuters, these are the passengers, and how they interact within the hall, and maybe involving in one or two activities, or the ticketing or the fare gates, being done within this hall, in which we're still going to be looking into. But this is just the first stage of it, and we see the movement of the passengers for different purpose, coming into the entrance, through the entrance, and exiting through the destination point here. And if I come to the point where I pause this simulation, we can see the number inflow source here, the numbers go to trend, and the pet sync. We'll be able to see the relationship between everything that we have here, or all the digits we have here. So if I'm going to pause this simulation, we can see 139 passengers have entered into the train station, or the subway entrance hall. Now, out of that, 102 are at the point of go to train, maybe trying to get their tickets, or trying to do one or two activities, engage in one or two activities within the simulation, or within the hall. It might be waiting, it might be ticketing, it might be the use of the information display, whatever it is. But this 102 are currently within the hall for one or two activities, or trying to buy their ticket also. And we can see 37 have already exited to the point of the already out of the simulation, or have been attended to, and they're out, maybe into the train. So this is the point. So when we look at it, 139 are in. So 102 currently being in service, and 37 are done. So they're already out of the, maybe inside the train, also whatsoever it is. And when we decide to add this 37 that are out, and this 102 that are still currently being processed, when we add it, it will give us 139, which is the number of people who are within that simulation at this time. So we can see the number keeps increasing the more people comes in. So if I play, I continue the simulation, you see the number keeps increasing. So 145, it keeps increasing. So 145 have moved from the point of entrance to the point of the go-to train. So 99 is being processed, and 51 is already out. So the more people coming in, they are being processed at the go-to train within the hall, maybe for one or two activities, like I explained. And now 62, 65, 69, 70 people at the pet sink, or the destination point, 78 at the destination, 82. So it keeps increasing, and people keeps coming in. We can see in that colorful forms. They keep coming in and they keep exiting at this point. So that is just the first phase of this simulation. So we would head into the second stage. of the simulation. So we can just close this for us to continue. We can close this, then move to the second stage. So in the second phase, that is where we are going to be introducing the fare gates in the subway layout. Now, we already have our layout. It contains the ped source, the movement of pedestrians into the subway hall. But what exactly would they be doing in the subway hall? So now we are going to be introducing the points where they can buy their tickets. Where is the point in which they are going to be buying their ticket? That is what we call the fare gate. At that point is where passengers can come into the subway or to buy their tickets they will be using to enter the to board the train. And like you said earlier, not everyone who are coming into the train station or who are coming into the hall are coming there to buy tickets. Some might have bought theirs online or whichever source, but looking at those who are coming into the train station that are coming there and also hoping to buy their tickets, then those are the people who are going to be making use of the fare gate, and we are going to be setting that up right away. So to be able to introduce the service line, well, we can you can see here we have the service with lines and service with area. The service with line is the one we popularly use or we're going to be using in this simulation because it shows the level of queue of passengers before the service is available to them. But with area is for those who have done theirs, who did theirs electronically. But for the sake of this simulation, we're going to be making use of service with line. And the same way we click on this or we drag it, you can just drag it into the point of the simulation, then drag it this way, then we drop it. So we can see for dragging the service with line, it has only 2 points. That is two service line. This is service one, service two. So just two service points in this simulation. But we can change the properties and increase the number of service points. If the subway hall you're trying to create, you notice that the capacity, because for what we have here, we are talking about a capacity of 4,000 passengers coming through. So there is no point we can have two service lines or two service points within the simulation. There is going to be a need for more in order to be able to accommodate the demand of passengers who are going to be needing the ticket. So then we can, like you said, we can click on this, come under the view, then the properties. So here the number of service, you can increase this to 6. Then also the number of queue. So this is the number of queue, the number of line of queue before we have the number of line for service. So 6 we have that. Then we can change the service. Rather than having it as services, we can change it to fare gate, because that is fare gate. So like we have it here. Yes, the fare gates. Then this is 6. Then this is 6. Then line point. Yeah. So this one, we have the type of service. The type of service is not, basically put it as linear. So that will be it. Then we can close this up. So when we close this, we can see we have the service with lines. We have 6 of them. 1, 2, 3, 4, 5, 6. If you want to increase it from 6 to 7, 8, I think we're going to be doing that later on. But this is just for us to have an idea of what it is like. Now, after when we've been able to do this, we need to now modify the process of flowchart. That is the flowchart. We need to be able to add the flowchart here where as pedestrians are coming in, they can be able to use this service. Because if we run the simulation, it doesn't have any effects without we having that connectivity within this flowchart to the service line. So, and in order to do that, we will be doing that with the pet service, because this is a service in which we've introduced. So we need to add the pet service to the flowchart. So for us to be able to do that, we need to create enough space to be able to introduce the pet service. So what we can do is increase this a bit to the front, then just move this like this. Make sure that, so we have that space, then we can bring in the pet. service in this form. So we can have the pet service here. So what we'll do next is to change the configurations. We come here, check the properties. So here we have it, the pet service. So rather than having a pet service, we can say at fare gates, because that is the point of the fare gate. Then we have for the service, we have where do we want the service to take place. It's still going to be the fare gate here at the point of the fare gate, linking it to the fare gate. Then the shortest queue, yes, we'll leave it as shortest queue. Then so we are leaving the delay time as maybe within minimum of 2 to 3 seconds. Yes, the possible delay time. Yeah, and I think that is it. So we close this. So we have been able to, from the inflow, we've been able to introduce the add fare gates, which represents the point of service. Then the to go train, then we have the pet sync. So after doing this, then we can try to run the simulation and how we see how it's. So I can say the movement of the passengers into the subway hall again. So rather than the first model, when we run the first model where they were just moving anyhow within the entrance, or you can see it's a little bit much more organized now. As they're moving in, they're going to the service line points, maybe for their tickets. Then they are being processed, and after being processed, then they can move out of the simulation. You can see at this point he's still here. There's nothing under the go to train because everyone is still at the point of the at fare gate. So here it's still 00000 because they're working at the fair point at the fair gates. But we have one who is about to head out at this point. So when this is processed, we see this becomes 1. So when this red line crosses this line, it becomes 1. So then it changes here. It becomes 1. Then we can see the numbers start moving in. So the more they are coming in, they are being processed at this service point. Then after when that is done, then they head out of the similar out of the to the train point. So you can say that is the movement. So if we want to increase the the flow movement, you can also do that at this point. So if we feel the 4,000, since the number we have here is about 4,000, if we want to reduce the delay point, you can see there is a little delay before they are being serviced in. You can see the delay, the queue, the queue, the queue. So that is for the number we are having. This is the queue point. You can see the passengers queuing at this point, the queue, the queue. So if we feel the number of the service lane is too small to service these passengers coming in, we can also increase it from 6 to 7, maybe from 7 to 8. It depends on whatever number we want to do, but you can see the movement coming in at this point. So if I decide to close this now to this point, click on the so when we click on this and we go under the properties, we can increase the number of service from 6 to 7. We can increase it to 7 at this point. So when we do that, we can run the model again. We can run. So now we have 1, 2, 3, 4, 5, 6, 7. Now 7. So we can run the model. So you see when we do that, when we have 1, 2, 3, 4, 5, 6, 7, we can see that we don't have much delay or much queue number of passengers on the queue compared to when we were using 6. The number of passengers on the queue has reduced, and this is the advantage of when we have more service lines. But it's also not available to have too much service line, but you need to be able to understand what the demand of the train station or the entrance hall is like before setting up the service line. And that is why we see there are some kind of stages whereby there are some temporary service line that have been implemented, most especially during the period of during high demand seasons, maybe probably during festive seasons. You can see there is a need to have more service lines being for that period. And the moment when we are off that peak season, you see you can go back to the regular service line, the number of service line. So this is just increasing it to 7. So then we move on to the third phase or the third stage. So looking into the third phase, which is the displaying the pedestrian density map, we have created a model simulation simulating pedestrian flow inside a subway entrance building. Now we need to be able to get some of the statistics on the flow. And in order to do that, that is when we make use of the density map. And this is the most powerful tool we can use in pedestrian simulation for this stage. So that is where we get to use the density map. So we will be introducing the density map into the model. So we are back to our layout, and in the layout now we come under the density map. This is the density map. All we need to do is to drag the density map and put it at the end part of this. And just have it this way. So this is what it's gonna look like. We had it to the end of the layout. So when we decide to run this model, when we are seeing that red um, critical point, that is when we have it at the red point, it shows high density at that point during in the subway. Or but when we have it as any other colors, or maybe let's say blue, that means there is low density. So that is the essence of this color. So what we do now is we run the simulation, then we see the introduction of the density map and the heat map. Yes, that is the word. You see the heat map. So we can see the heat map since we've been able to introduce the density map. So rather than just having the dot showing the movement, so this shows the density. You can see at this point the colors showing that it is within this range. You can see the colors are based on the movements in the simulation or in the model. You can see. So So this is just representing the heat map, showing the density like I explained. So this this can go on for a while. And this is just the third phase, that is the introduction of the density map. So rather than what we've been having before, then this helps to show the critical places where there is concentration of the movement of the pedestrians, and we can see that from this simulation. So we'll move on to the final phase of this model. So moving into the phase 4, that is where we had the ticket vending machine into the model. So without wasting much time, let's head into that. Let's quickly do that. So to be able to achieve that, we also still need to make use of the service with line, because we need to add the vending machine service into the model. So we come here, click on the service with line, then we drag it into this point. Maybe probably you can just drop it here. Since we know the service here is about 7, so we need to increase this one. But before we do that, we need to rotate this. So in order to rotate, you can just, when you move it, there's this sign that comes for rotation. So we have this. So then we can go back again to click on this to increase. So we come under the properties, then we increase it. So this time around, we can change this to ticket machine. Because that is what we have, the ticket machines now. And this is now 7. We also increase this to 7. So this will leave this one as points, not linear like we did with the previous one. So we'll leave it as points. So this will still remain as levels, and the information remains. So this is it. 1, 2, 3, 4, 5, 6, 7. So we have been able to introduce the service with lines. But now that we've been able to introduce the service of lines, we need to also be able to introduce a new block into this flowchart, because we introduced the add gates for this. So we need to introduce a flowchart also to be able to accommodate this into our model. So before we proceed, let us space this enough to be able to accommodate it. So what we try to do is click on this just to increase this here, then click on this just to maybe increase this, then this one also, and bring it this way. So we have the space to be able to introduce a new block into the flowchart. So we are going to be introducing the pet select output, that is the decision making output or point, into this flowchart, and we're also going to be introducing the pet select and pedestrian service into it. So the first thing is we drag it in this way. That is the pet select output, and we can also use the opportunity to also drag in the so we have the two of them being dragged in. So since we still have enough space, I can just reduce it by bringing these ones a bit closer, so we have something like this. But at the end of the day, we still need to be able to connect the pet select output to the pet service and connect it to the FAREGATE, because there has to be a connection. We call them the connectors. So in order for us to be able to activate the connectors, there's this point here. You just double click it, we extend it out a little, then click, it comes down, click, then it joins up here. So you see, this is what it's going to look like. And at this point, so we double click to activate the connector. Then after bringing it, we take it up a little, then we join it here. So it shows the connection to the FAREGATE. So this is what we would have. So we've been able to connect it, the inflow source, to the pet select output, then connecting to the pet service where the service is being rendered. And after the service here of the then it's leading to the at fare gate, then to go to trains, then the ped sync. So we know this is the vending ticket. So this is the point where the vending machine, the ticket, the vending ticket machine is. This is the point of the service here, and we've been able to introduce it. This is just the decision making points coming here to the at fare gates, then the go to trains, then the ped sync. So with this now, we let us rename. Let's just work on the properties. So, so here we change the name rather than using the pet select output. We can just change it to route passengers. So then after doing that, we have the probability here. So for the first probability, we can change this to maybe 0.9. Then the second one we can change it to 0.1. Then for the other ones, we can just keep it at 0. So what it means is that in this flow, we try as much as possible to assume that the number of passengers that they've already bought their ticket is actually higher. That is why we have a higher probability here. That is the number of passengers who are coming in. Most of them had already bought their ticket. So the reason why we do this is if we have a higher percentage or higher probability that people who have not bought their tickets are more, then it shows that this particular part of the hall will be much more congested. That is, since majority or a larger percentage of probability of people who are coming in or the passengers coming in have not bought their tickets. So, but if most of them had bought their tickets, so some of them don't need to go through the process of the buying of the ticket again. They can just go through the phase of the service, then head to the train point. So that is just what the whole probability here is talking about. Then you can this. So at least just to be sure our information is still correct. Okay, it's still there. So we come under the pet service also, then the properties. So instead of having pet service, let's just change it to at tvm. Yeah. So with this we have what service is going to be. We're using the ticket machine, that is the ticket machine, connecting it to the ticket machine. Then the uniform, the delay time, we have to change our delay time to so for the pet service we change the properties. So rather than having the pet service, we can put at tvm. Then this here, this will be the ticket machine. Yes. The shortest queue. Yes. Now the uniform is a minimum of 2 seconds. The delay time is a minimum of 2 seconds to a maximum of 3 seconds. But we won't use this. We'll have a triangular view of it. So what does that mean? That means we are having 3 points, which helps to say we have a minimum of 7 seconds, then we have 12, an average of 12 seconds, and a maximum of 40 seconds, because anything is possible when there is a delay. So it is quite important for us to be able to spell it out this way in that sense. So minimum delay time of 7, minimum delay seconds of time of 7 seconds, an average of 12 seconds, then a maximum of 40 seconds. And this helps us with the last part here, and this is it. So after when we've been able to do this, then we can run the model. So when we run the model, we can see from the behavior that some passengers first go to the ticket vending machine to buy a ticket. Then after buying the service, after buying the ticket and pass through the fare gate. So this is the point where they buy the ticket. That is the vending ticket machine point. Then from there they go to at fare gates, and from this at fare gates, then they can go to train. That is the point of destination here. So this is just a tutorial on how to introduce the target point into the layout or into the flow, just like we did. First, we brought in our image. After doing that, or the layout, after introducing the layout, we're able to create our entry point and the destination point, that is the target line. So we renamed them. Then after doing that, we were also able to introduce our service line of service for at fair gate. That was what we did. We're also able to look at how we can increase the number of our lines. Then after that, we also introduced our density map. And after the introduction of the density map, we're able to introduce the add vending tickets machine point. And we can see that we can now see how the behavior of the model with the introduction. So far we can see 79 people are already into the flow. Then the 79 are being serviced at the point of the route passengers to the at TVM, that is the vending machine point. Then out of it we have three of them who have been processed to the go-to train. Then one is already at the destination point. So this is just a tutorial video using the subway pedestrian flow in a subway hall. So this is just a video or a tutorial video about it. So we're going to be looking into some other ones. So this is just for the train station or a train station. We're still going to be looking into that of the road intersections and the rest. So I hope if you have any question, you can just drop it in the comment section. Then I'll be happy to respond to them. So in the event of none, I'll see you in the next video. Thank you.